Hello everyone, today we will discuss about the change of state. We have already discussed that there are three states of matter: solid, liquid and gas. Now we can change one state to the other by either increasing temperature or decreasing temperature, or by changing the pressure. Now let us talk about temperature change. We can convert a solid substance into a liquid substance by increasing the temperature. There are two ways to do so. One is called fusion, the other is called melting. Similarly, if we further increase the temperature, the liquid can convert into gas through two processes. One is called vaporization, the other is called evaporation. And sometimes a solid on heating directly converts into gas without going through the intermediate liquid state. This is called sublimation. This is called sublimation. Now, why are there two processes? Why are we talking about two processes in each of the changes? Because sometimes the change occurs on its own and sometimes we have to induce that. Like if we take solid ice, then at room temperature that solid ice melts into liquid. But if we talk about wax, then we have to burn it, we have to heat it so that it melts into liquid. Talking about liquid to gas, vaporization and evaporation. Evaporation is the process where a liquid changes into gaseous form below its boiling point, and vaporization is like we are steaming it, we are going to boil it. So there are two processes, one that occurs on its own while the other that we have to induce. Now talking about points, what is melting point, what is boiling point? Melting point is for solids. It is that temperature where it starts to melt. For liquid we have boiling point. The boiling point is that temperature at which the liquid starts to boil and convert into gas. We must remember that a certain amount of heat goes into breaking down the bonds between solid particles so that they can loosen up and become liquid. That extra amount of energy that we have to supply is called latent heat of fusion. Similarly, the liquid particles again, they further need some extra heat to convert into gas. That extra heat is called latent heat of vaporization. Now let us talk about coming back from gaseous state to liquid and then liquid to solid. Again we will have two processes. One is called condensation, the other is called liquefaction. Again, if we talk about coming back from liquid to solid, then we have freezing, we have solidification. Like condensation occurs just as a case of fog. The water vapor, it loses its temperature and then condenses to form liquids, while liquefaction is the example that we can take is our LPG cylinders. Gases are pressurized into a cylinder so that it becomes liquid. Talking about this phase, freezing is like freezing water to ice, and solidification like if the drops of wax they fall on a surface, then after some time they again convert back to solid from liquid state. That is called solidification. And sometimes the gas directly changes to solid. That is called sublimation also, and we have another name that's called deposition. So here we have what? The entire changing phenomena of the three phases of matter, three states of matter. Two ways, by increasing the temperature from solid to liquid. Again two ways for liquid to gas. Again if we talk about coming back from gas to liquid, we have two ways, and liquid to solid again two ways. Moreover, we have to remember that there are extra amounts of heat required or energy required that are known as latent heats. Latent heat of fusion, latent heat of vaporization. We often come across certain situations where boiling water is causing less burning effect but steam is causing more burning effect. This is because boiling water has only temperature of 100 degrees Celsius, but steam, the gaseous form, has 100 degrees Celsius, but also it has a certain amount of energy that has been absorbed to break it from liquid to gas. Similarly, ice at 0 degrees Celsius is more effective in cooling than water at 0 degrees Celsius because the ice has lesser amount of heat in it, but the liquid at 0 degrees Celsius, liquid water, that has latent heat of fusion in it. So ice at 0 degrees Celsius has more cooling effect. Now, talking about evaporation. Evaporation is very important in our day-to-day life. Evaporation is the process where a liquid changes into gas without reaching the boiling point. Like water, if we have water spilled somewhere, it will disappear after some time even without boiling. That is called evaporation. Now, what are the factors that affect evaporation? The factors that affect evaporation are area of surface, second is temperature, third is wind speed, and fourth one is humidity. So how are these four factors affecting evaporation? See, when we accidentally spill some water on the floor, then what we do? We mop it. By mopping it, suppose the water spilled over this much area, but by mopping it, we are spreading it to a larger surface. More the surface, more is the rate of evaporation. So if we mop the floor, that means that we are increasing the area. Increasing the area efficiently increases the rate of evaporation. Now, what is the effect of temperature? More the temperature, more is the rate of evaporation. We have certainly observed that during rainy days, when the temperature is comparatively lower, it takes time to for the water that we have mopped to evaporate. But during hot sunny days, it easily evaporates. Coming to the next point, wind speed. Obviously, we have observed that when we mop the floor, then what do? We just switch on the fan. Switching on the fan increases the wind speed, thereby increasing the rate of evaporation. Coming to the fourth point, humidity. Humidity is actually the amount of vapor, the amount of water vapor contained in a certain area's atmosphere. More the humidity, more is the content of water vapor. Now, if the air has already a higher amount of water vapor in it, that is higher humidity, then the tendency of evaporation decreases. So, greater the humidity, lesser is the rate of evaporation. But for these three cases, the rate of evaporation increases, whereas for the case of humidity, it decreases. Now, why is evaporation so much necessary? Like during summer we wear cotton clothes, because cotton clothes, they are weaved in such a way that they have holes in them. They have tiny holes in them. These holes help in taking out of the vapor form of our sweat, thereby decreasing our body skin temperature, and we feel cool. Now, that sweat, when it comes out, secreted out from our body to our skin, then it absorbs our body heat and then changes into vapor form. That vapor simply goes out through those holes and we feel cool. Another example would be that of when we keep water in earthen pot. What happens? It becomes cool after some time. This is because earthen pot, they have very tiny holes in them through which water just capillaries out. It seeps out. When the water at the outer level seeps out, then what happens? They just take the temperature from the inner water particles and evaporate it. In the process, the inner ones lose temperature and become cool. So we have many other examples where evaporation helps us in our day-to-day life. It is very essential. Moreover, we have come across recently that there are 5 states of matter. The 4th one is called plasma. The 5th one is called Bose-Einstein condensate. When a gas is heated to a very high temperature, that thing breaks into some charged particles, very highly heated charged particles. That is called plasma. Our sun is made up of plasma. And when we cool a gas below a certain temperature, then we call it Bose-Einstein condensate. At that temperature, the motion, the molecular motion, the particle motion decreases to a very drastic low level. So this is in short matter in our surroundings, the first chapter of science for class 9. Thank you.